What is a reward in robotics reinforcement learning? Imagine teaching a robot to do a task, like picking up objects or navigating a maze. How does the robot know if it is doing well or making mistakes? That's where the idea of a reward comes in. In reinforcement learning, which is a type of artificial intelligence used in advanced robotics, a reward is a number that tells the robot how good or bad its recent action was. Think of it as a score that guides the robot to learn better behaviors over time. When a robot interacts with its environment, it observes its current situation, called a state. It then chooses an action, like moving a joint or turning a wheel. After doing that, it gets a reward based on the result. If the robot performs a desirable action, it gets a positive reward. For example, if it successfully picks up a box, it might receive a reward of +5. If it hits an obstacle or drops the object, it might get a negative reward, like -10. These rewards help the robot understand what actions lead to success and which ones to avoid. The main goal of the robot is to learn a strategy, called a policy, which is a plan for choosing actions based on what it observes. The robot's aim is to maximize the total amount of rewards it gets over time. This means it will try to do things that lead to more positive outcomes and avoid actions that bring negative results. The reward system is essential because it shapes how the robot learns to perform complex tasks, like assembling parts or navigating unpredictable environments. Designing the reward function is very important. It needs to accurately reflect what we want the robot to do. For example, if we want a robot to reach a specific location, the reward could be based on how close it gets to that point. If it moves closer, it gets a small positive reward. If it moves away, it gets a penalty. Rewards can be simple or complex, depending on the task. Sometimes, rewards are given continuously, like a score that increases as the robot gets closer to its goal. Other times, rewards are only given when the task is fully completed, which is called sparse reward. In robotics, actions are often continuous, like adjusting joint angles or motor speeds. This makes designing the reward function more challenging because the feedback needs to be frequent and clear. Modern reinforcement learning uses deep neural networks to help robots learn these policies without needing a detailed model of their environment. The neural networks help the robot figure out the best actions to take based on the rewards it receives. To sum up, a reward in reinforcement learning for robotics is a numerical signal that tells the robot how well it is doing at each step. It guides the robot's learning process by encouraging actions that lead to success and discouraging those that cause failure. This simple idea is what allows robots to learn complex skills through trial and error, becoming more autonomous and capable over time.